this computer. So looking at Mike Platoon's week 2 curriculum, we covered object-oriented programming yesterday. We did a little bit review today. We're going to keep on doing that throughout the rest of the week, except for today. Today, we're going to be focused on recursion. All right. So topics covered today: recursion, the call stack, understand the difference between a recursive function and an iterative function, implement recursive solutions to challenges, and explain what the call stack is. So first, let's talk about the call stack. This will come into play with regards to the recursion. Has anybody ever heard of the call stack or the execution stack?
Do you mean like the data structure?
Well, it like represents a data structure, like the stack, yeah.
Isn't it where you store information on a first in, last out basis, I think, for a stack?
So yeah, that's how it works. Yep. So the call stack is essentially in JavaScript, it's where it stores all the functions that are currently being executed. So let's take a look at it. So it's a stack is exactly like it's a data structure. You're correct. So if you think of a stack as like a stack of pancakes, when you create pancakes, you put them on the plate. When one's done, you keep putting them on top of one another, and you put that plate in the center, and then people can take them off the plate from the top. So it's a last in, first out data structure. So the stack. So the call stack stores executions of code on the stack in the order they are executed and removes them from the stack when they are done executing. And this will make sense when we get into recursion, but yeah. So when one function starts executing and it's continuously executing, and another function gets executed, it's continuing to be executed, and it keeps adding on top. And as long as all these functions are executing, they'll be placed on the call stack. And when one's done, it gets taken off the call stack. And as each function is done executing, they get taken off of the call stack. So here's a little.
Is that like what happens when you nest loops?
Not with nested loops, because a nested loop, you're only calling the function once, and it's just looping through. So the function's only being called once, whereas the call stack, or when we're calling recursion, you're going to be calling functions multiple times, and that's why you'll get the call stack, or you'll get multiple functions on the call stack. So this is where you get to kind of choose of how you want to solve problems iteratively or using recursion. That kind of answer your question?
Yeah. Thank you.
Okay, cool. So can everyone see my screen and see my cursor? Yep. Yeah. All right. So this is like a visualization of how the call stack works. So on the left-hand side, I've got 3 functions. I've got a function called main, I've got a function called second, and I have a function called third. And at the very bottom of this file, I'm invoking the main function down here. So when main starts executing, it console logs. So console.log is just a function. Log is literally just print something to the console or the terminal. So it prints something to the terminal called main starting. And once console.log, it like immediately starts and then stops executing. So right when console.log, it starts logging, and once it's done logging it to the function or to the terminal or the console, it stops executing. So when main is executed, it console logs main starting, and then it calls the second function. So it starts executing the second function. So which takes in 3 and 4. We're not doing anything with those inputs, but so it starts executing num1, or starts executing the second function, and then the second function starts console log second starting. And then the second function invokes the third function. So the third function is invoked, is executed, and it console logs third starting. This entire time, second is still running, and so is the main function. So it's still running. And then once third returns third removed from the call stack, so then it comes up here, then it second returns second removed from the call stack, and then finally it returns, it jumps up into main, then main removed from the call stack. So let's just kind of show you what this looks like. So when I start executing, main gets added to the call stack. So main up here, then main console logs main starting. What's going to happen next?
It will call the second function with the parameters you put into, or arguments you put into the main.
So is console log still going to be running then? This first console log?
I think so, yeah.
It's still going to be executing?
I thought you said with console log, once it goes, it stops.
Yep. So once console log prints something to, or logs something to the console, it's done executing. So it just immediately is done executing. So if console log logs main starting to the console and is done, what should happen with the call stack?
It will.
Oh, it will be removed.
Yep. So this console.log will be removed from the call stack. And then Emma, you're right. Then second is going to be invoked. So second is invoked like that. So now we're in second. Main is still running this entire time. And now, back up. Then we have console log second starting. And then once that's done executing, gets removed from the call stack. And then third is executed right there. So now we're in third, in the third function. And third starting, and then third is removed. And then once we return third removed from the call stack, what should happen? Kind of says it right here.
It should pop off the call stack.
So third removes from the call stack. Now we're back up in second. So third is done. Now second should return. Second removed from the call stack. And then finally, so second's done running. And now finally the main is done. So now we have the call stack is empty. So let's continue with this. And I want to show you some more stuff. So what do we got? App.js. Okay. Can everyone see this?
Yeah. Tom, real quick. So is a call stack a like structural or physical limitation of a computer, and so you have to call things in order, put them on and take them off in some order? Or do you do it, you utilize a call stack strategically because there's some reason in which it's the best way to do it?
So you aren't utilizing the call stack. Like, you're not manipulating anything. The call stack is specific to, there is a limitation. So when we get into not infinite loops, but yeah, something like infinite loops, if you recursively call something, or if you have a function like how we did before, a function calling a function calling a function, if you keep doing that over and over again and there's no return statement, or what we call a base case, then your memory is going to run out in your computer and your browser is going to freeze.
Got it. So this is just how computers work.
Yeah, specifically, yeah.
Thank you.
So I've got pretty much exactly what we showed you before in the right here, the visualization. And VS Code has some nice features. We can add breakpoints here just by clicking on the sides, and it's going to add some breakpoints. So I'm going to run this as a debugger in VS Code, and it's going to show you something called the call stack, and I'm going to show you exactly kind of what we just visualized in the slides. Oh, what is this? Node.js, there we go. So right here, I'm executing. Is this running? Why isn't it working? Oh, great. What happened? So, okay, yeah. So I'm going to refresh this. So I'm running this program now. Did it run? All right, so if we see up here, we have the call stack up in the upper left-hand corner. And if I step through this, I get the main function running. And if I keep stepping through, oh, what's going on? Oh, I guess it's that part. So second starts running, and you can kind of see where in the flow of things where it's at. So then we have, why is this? I'm actually quit out of this. But yeah, so we have third starting now, and it's console logging third. And now you're going to see third popped off the stack. Why isn't it? So the third got popped off the stack. And now we're in second. Second's right here. It's going to console log there. And now second's going to be popped off the stack. And then main's going to be popped off the stack. Yeah, I was running into issues with this before in here. So I'm going to show you something a little bit different. I'm going to actually show you it in the browser. So don't worry about any of this stuff. We'll get to this later. All right, this is exactly kind of what we had before, but now we're in Chrome. This is where the call stack exists. We have the call stack over here on the left or up in the right, and we have all the code here. So if I just refresh this, it executes my JavaScript right here and it prints everything out, but I'm going to add a breakpoint right here, and then we're going to watch the call stack in action. So I'm right here. It always puts anonymous on here. Initially, it's just how it works. And now I'm going to step through this, step into the next function call. Let's do right there. And see now main is popped on the call stack. So I'm inside of main. Now I'm going to console log main starting. And you can see right down here in the console, main starting. So I haven't reached second yet, but now I'm going to hit second. Now second is on the call stack. Now I'm in here, I'm inside this console.log. You're going to see down here the console.log. Second starting. Now I'm right here, right before third is starting. Now once I start third, third is starting. Now I'm going to console log third, starting right there. And now I'm going to return third. So third is done executing. So third was removed from the call stack. And now second's going to be returned or removed from the call stack. And now main is going to be returned from the call stack. And now it's officially kind of done. Now, let's show you something else. So instead of using what we just executed, we literally just executed this. But now I'm going to execute this method. So if I refresh this, I'm in this countdown. So I have this method called countdown, and it returns itself multiple times. So if I step in, I get countdown called once. It's going to count down, it's going to console log the countdown number, 5. I'm adding countdown again onto here. It's going to count down or console log 4. Now it calls countdown again. So I've got 3 countdowns on the call stack. Now it's got console log countdown 3, adds another countdown to the call stack. 2, I'm just going to keep going. It's adding all these countdowns to the call stack right here. And then finally, when the number equals 0, just going to keep on removing all the functions from the call stack. This is what recursion is. So let's go back. So with that, here, delete this. I'm back in OOP review. So I'm going to, the reason why I show you what the call stack is because it's a function that calls another function and calls another function, and it keeps adding layers to the call stack. So to challenge less, make directory, recursion, cd recursion, touch recursion example. So I'm just going to open this up, and this is all going to be in JavaScript right now. So what questions do you have about the call stack and a function calling a function that's calling another function?
Could you show us how to open up that Chrome debugger
Oh, yeah, sorry.
again? Thanks.
So we'll get to this later, but it's Command Option I, or you can go up to this little 3 dots up in the upper right-hand corner of Chrome, go to More Tools, and go to Developer Tools right there, and it should pop up open right here. But yeah, Command Option I just opens and closes it. So recursion is literally, it's like it or not like iteration. It's an alternative to iteration. So instead of using a for loop or a while loop, you can use recursion, where a recursive function, does anybody know what a recursive function does?
It calls itself. It's kind of like it's a way to iterate a little bit more eloquently than you would with a for loop. So if you don't have the data that you need yet, you could just call the function again with making the parameter. You're adding on top of the parameter when you call that function. So the second time you call the function, the parameters are slightly adjusted to the new data.
Yep. So it's a function that calls itself until a certain condition is met. And there's 2 things that you absolutely need in order to have a recursive function work. Step 1 is a base case. It's at what point should the function stop calling itself? So define a base case. When should the function stop calling itself? So like before, when I was showing you in the browser, the call stack with this countdown, we have this countdown. The base case is at what point should the function stop calling itself? So right here would be the base case. So it just returns console log. Every other condition, it should return itself with the input number -1, and we'll get to that. So the step 2 that you need to define is define the essentially the recursive case. When should the function call itself? So let's run through some examples. So we'll go through iteration using for loops, and we'll show the alternative equivalent in recursion. So has anybody watched those like SpaceX launches recently or ever?
Yes.
They're awesome. Yeah. But we're going to create a function called Spacex Countdown. Or let's do SpaceX Countdown. And it's going to take in a number. I'm using a fat arrow function here. And if I wanted to count down from like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, liftoff is what I want it to end. So the iterative, if I wanted to use this iteratively, I can do like for let I equals num, I is greater than 0, and I'm decrementing each time. And then I can say console log I. And once it's at 0, I can say return console log, liftoff. Or like we have liftoff for Falcon Heavy or something like that. That's the name of their. So if I actually wanted to execute this, I can SpaceX Countdown and pass in like 10. And now I'm down here in the console or in the terminal. And if I want to run this, I can do node SpaceX or node recursion example. And now I get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff for Falcon Heavy. Does anybody have any questions about how I did this? Simple iteration with using a for loop. Could use a while loop as well. But now let's use recursion to do the same thing. So I'm going to do this, copy this down here, and just delete all of this. So what are the two things we need to do? What are the two steps we need to do when we want to create a recursive function?
Define your end condition.
So the first thing we need to do is define, as you said, the ending condition is what is called the base case. If you don't have a base case, your function is going to continue to run and your computer is going to stop working. It's going to crash. So define a base case. What is our base case of when we should console log we have liftoff for Falcon Heavy?
When num equals 1?
When num equals 1. Are you sure it's when equals 1? Let's check it out.
Or
So
when num equals 0?
When num equals 0. There you go. So when num equals 0, return console log Falcon Heavy. Or we have liftoff for Falcon Heavy. So we can say if num equals 0, return console log Falcon Heavy. Else, what should we, else, obviously, if it's not the base case, it might be the recursive case. So what's the recursive case?
You'd return num plus, and then that's when you would recall the function.
Return,
Num.
what is num?
The original number passed in.
So, okay, so I'm returning num.
Plus, or
Do I even need to return num?
no, sorry, I was thinking of adding all of the. I
Yep.
forget we're just console logging.
Yep. So yeah, probably I want to console log the number here, just so we can print out the number. And then we should return,
Could we return the SpaceX Countdown num -1?
yep, num -1. So we're initially passing in, say like 10, comes into here, let's say like start with 3. Passing in 3, does 3 equal 0? Nope. Let's console log 3, and now we're going to return, we're passing in 3 minus 1, which is 2 now. So now we're calling SpaceX Countdown again with 2 passed in. Is 2 equals 0? No. Console log 2, return SpaceX Countdown. 2 minus 1 is 1. Calls it again. So it's a function that continues to call itself. So if we look at here, here's like more examples using recursion to solve problem requires 2 cases: a base case, the condition in which the function stops calling itself, and the case in which the function returns itself. But if we explicitly look, this is another function or another recursive function. It's a function that calls itself continuously. So sum up to is a function that we add everything up to a certain number. So we want to sum every single number up to 5. So 0 or 1, 0, 1, 2, 3, 4, 5. We want to add up all those numbers. So if we pass in 5, if 5 equals 1, return 1, else here's our recursive case. We want to return 5 plus 5 minus 1, so it's 4. So now we pass in 4, do the same thing, pass in 3, pass in 2, pass in 1. So it's a function that keeps on calling itself. So if we, just like with the SpaceX Countdown, pass in a number, if this condition is met, it stops executing, it stops calling itself, it just returns console log. Else, it's going to return itself with the original input -1. So if we comment this out and clear it and run that again, we get the same thing. What questions do you have about recursion?
Hey, Tom, what's the point of having return in that function? Can we do the same thing without having return?
Right here?
Right. And also within that if statement.
So return, you need a return statement to indicate when to stop executing the function. Because if we just had like console log here, or do you mean like?
Yeah, I feel like if we just remove all returns, it will perform the same thing.
So if we do something like this,
right?
That's what happens. Because we didn't actually, a return statement tells a function to stop executing at some point.
Okay, gotcha. Thank you.
So you need a return statement.
Would a break or a pass suffice?
A break. But where would you put the break in a recursive
After
statement?
your console log.
Like break?
Yeah.
Clear.
Isn't a break used for a loop?
I never use breaks. I've never used a break before. I think, yeah. If your code is written correctly, you shouldn't have to use any breaks or anything, because like, yeah, you just shouldn't have to.
Yeah. A brake is like hitting the emergency brake on your car. You really shouldn't have to do that.
Yeah.
I have a question with if we applied this to like the 99 bottles, you just put like a else in your base case when we got like down to like 2 and 1, or would like how?
I'd have to look explicitly on 99 bottles, but it would be like, once you get down to 2 or 1, then execute those other the other logic of that. So yeah. So let's keep on going. So that's one way. Let's do another example. Let's do like adding all elements. That's not how you spell it. And so we can say let add array. It takes in an array, and we want to add all the elements into that array. So what's the base case? So if we're inputting an array, so if the array.length equals 0, I want to return something. Don't know what I want to return yet. So with an array, I want to grab each element off the array. So I can say I want to grab the first element off of the array. So array.shift, and that manipulates the very first, or that manipulates the array. So if I can say like, I just want to show you kind of. So we say like let input equals 5, and then add array input. I can console log array. Down here in the terminal, I'm going to run this. So my initial input array was 1, 2, 3, 4, 5, but when I shifted the first element off of it, it is now missing that first element. So with that, I can return the very first element of that array. Otherwise, I can return first plus add the array and add the new array with the first element shifted off of it. So the first element would be 1 right here. So here's first equals 1. And that says if the array.length equals 0, no, because the array.length the first time it goes through is 4. Because I've shifted off the first element, so it's 1 less than it was the original input. So it doesn't reach the base case, so it goes to the recursive case. So this is 1 plus add array, and I'm passing in this new array into here. So this new input is 2, 3, 4, 5. Shifting off the first element of the 2, 3, 4, 5 array. So now this is 2. So this value is 2. Or sorry, this is 2, and then it just keeps on going until the input array is only 1 element long, has a length of 1, and I shift off that only element out of that array. So now the array is 0. The array length is 0. So then it just returns first. So if I run that, whoop, what's going on? Whoop. Let's do console log. Uh-oh. 15. So let's just like console log the input array. I want to show you. So initially, the first input is this input, 1, 2, 3, 4, 5. We shift off the first element. And so now we input 2, 3, 4, 5. Come up here, 2, 3, 4, 5 is input in here. We console log that, shows up right here. We shift off the first element. So we shift off 2 at that point. But the array still has a length of greater than 0. Then we return 2 plus this new value, this new input, 3, 4, 5. So 3, 4, 5 gets input into here. We console log 3, 4, 5, which is where we're console logging here, all the way down until 5 is input at the very last one. So 5 gets input up here. We console log it. That's where it's being console logged. We shift off that first element. So we just take out 5 of there out of that array. So now the array, that length is 0. So now we come into here. So this array.length does equal 0. And now we just return 5. What questions do you have about that? It's kind of hard to wrap your head around the first few times.
When the problems get really big, does recursion become not an option because of how the call stack works?
No, you rarely ever reach the maximum call stack. Yeah. And the reason why we use recursion over, say, iterations sometimes is when you're dealing with algorithms, you want to break down a problem such as searching through something, and you want to keep on grabbing, inputting, essentially calling itself with different inputs until that one input is met, or until that one condition is met, and then you would find whatever you're trying to look for.
Yeah, and recursion is used a lot in video game development. For example, pathfinding algorithms require recursion. I don't know if there's an iterative way to do that would take so much longer than a recursive solution in that particular case, for example.
Yeah, if you're searching through something to find a specific value, generally you'd want to use recursion. And a lot of algorithms, the optimal way to do that, to find something, is using a recursive solution.
Thanks.
So we can keep going. Like, for example, let's do one more and then we'll break. And you can be back at like 120 or whatever. Like factorial. What was the original factorial? So like let factorial equals num. So the base case, so you want to grab all the elements or multiply all the elements up into like 5. You can say like if num equals 1, return 1, else return num times, call factorial again, and do num minus 1. So if you call factorial, 5. Console log it. Down here in the terminal, run that, we get 120. And we can just console log the input just to visually show you what the input is each and every time. 5, 4, 3, 2, 1, then we return the answer. So with that, does anybody have any questions about recursion? So the most important part is defining a base case, so when the function should stop calling itself, and then define the recursive case, when should the function actually call itself, but with a different input in it. So for example, and if you don't define a base case, so if I comment that out, I clear, you'll see what happened before. So clear. So if I didn't define a base case, it comes in here. If I type in 10, it's going to console log 10. It's going to call itself 10 minus 1, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And it's just going to keep going because it doesn't know when to stop calling itself. And that's what happens. So it executed it a lot of times. It went all the way down to 12,000 something, negative 12,430. And then this is what you'll get. Maximum call stack size exceeded. And then it'll break. So with that, you can kind of go through here. Here are some examples.
Is maximum call stack size, is that defined in the language or does it depend on your hardware?
Like the actual, I think it depends on your hardware. But usually whatever program you're running, or whether it's VS Code or up in a REPL, it kind of knows like, hey, there's probably, sometimes it knows like, hey, this thing is being called a lot of times. I'm just going to stop calling it because there's probably an error in it. All right. So your assignment today is recursion. And what you have to do is go back and do factorial, palindrome, 99 bottles, and Roman numerals using recursion. And then once you do that, binary search is a very popular searching algorithm, and a really popular interview algorithm as well. It tells you trying to find a number in a list of numbers. So if you're giving an array of values, and then you need to return either the index of where that value exists. So you can use a for loop by starting at the very first index and going and seeing if what index that value exists in. But say you work for Uber or Google, and you have billions of lines of code or rows of data, like an array of like a billion, and you need to find a single value in that array. So if you start from 0 and go all the way down to billion, it would literally take you, like a computer, a long time to do that. Because what if the value is at the very end of that billionth length array? So binary search is a way to break that down, that array, into smaller arrays, and calling itself by passing in the array as it gets smaller, and until you find that number. So, and you can read more here. But yeah. So does anybody have any questions?